So, question 2. This one is asking us to determine whether the following pairs of elements can form ionic compounds. Okay? So, ionic or non-ionic. Now, the base for ionic, we may have covered this already, but just remember, ionic is a metal and non-metal, typically. And covalent, well, non-ionic, are typically two non-metals. Now, that's usually what we go with, right? Now, there's also some situations where we're dealing with the actual bond itself, whether it's ionic or covalent. That one we'll delve into more detail later, but for now, when it's asking for the compound itself, whether it's ionic or non-ionic, we usually look at whether it's a metal with a non-metal, and then if it's two metals together, that's just a metallic compound. But point being is that later on we will have to look at the electronegativity to really see if the bond between those two elements is an ionic bond, a covalent bond, and that can be broken into whether it's a polar covalent bond or a non-polar covalent bond. This is just a preface because we might delve into it in the later questions, okay? So the first one we have is iron and chlorine, okay? Fe and Cl. Alright, and depending on the iron, sometimes you have FeCl3, FeCl2. The point being is, let's check it out. So iron is definitely a metal because it's in the transition metal area. Okay, and let's see here. And now chlorine is a non-metal. So here, what I'm actually going to do, just so we cover all our bases, I'm going to add the electronegativity as well, just to double check. So your ranges go for non-metal covalent bond, not non-metal, non-polar covalent. The range is typically 0 to 0.4. Okay? For polar covalent, it's typically a 0.4 to 1.6, around there. And now, ionic bond is typically 2 to whatever the max is, which is something like fluorine with something else, like the bottom one. I think it would be like francium or something, because electronegativity increases like this on the periodic table. Now you're probably wondering what happens between 1.6 and 2. So the rule of thumb is if it's between 1.6 and 2, you have to check now, again, as we mentioned before, if it's a metal or a non-metal. A metal would form an ionic bond. A non-metal would still be considered a polar covalent bond. But that's the thing, you can have, in rare instances, some metals that do bond with non-metals, but it's technically a polar covalent bond because of how weak it is. It's not really forming that ionic bond yet. Okay? But enough of that preface. Let's just get right to it. So iron actually has an electronegativity of 1.83. Okay? And now, let's just do some quick calculations here. 1.83, 3.16. That's around, okay. Give me a quick second here to make sure. I know I have a calculator here somewhere. Alright, well, I guess we're using the computer calculator for now. That's okay. It's 1.83 minus 3.16. So, this one is, wow, interesting. 3.16. Just make sure I'm looking at it right. And iron, 1.83. So technically, this one, well, according to the calculator, is 1.33 difference. So now this is one of those weird scenarios because this polar covalence range and even this rule set does vary, and that is where we have the tricky solutions like these. I'm gonna go ahead and say in this instance that iron chloride is going to be an ionic bond because iron is a metal. I do feel like maybe we can stretch this out to have a wider range, because as you see, especially with the transition metals, they get pretty close. So when in doubt, I would just assume metal and non-metal and just move that over to an ionic bond. Okay, so that would be for iron. Now for the next one, they did ask for oxygen and magnesium, so Mg and O. Okay, so oxygen does have an electronegativity of 3.44. Magnesium has 1.31. Okay, 1.31, 3.44. This is a lot more clear cut because this one gives us 2.13. Definitely an ionic bond. Okay, fills all the criteria. It's a metal and a non-metal, and it has a great electronegativity. So now let's look at the other ones. Fluorine and sodium, so that's NaF. Okay, sodium has 0.93, and fluorine is actually one of our strongest electronegative thing, 3.98. I don't really have to do the math. This is like close to 3, so this is definitely going in the ionic part because remember it's a metal and a non-metal. Potassium and sulfur, so P and S. I'm just gonna put them like that because I don't know how they form into like the actual compound. So potassium has 2.19, sulfur has 2.58. Now this together is like, what is this? That's like, that's 30.39. Should be about that. Yep, 0.39. And with this is definitely going into our non-metal. In fact, well, they're both non-metals, so they're definitely going into the not ionic section. I'm going to just add this just in case, but in a sense this is ionic and this is not ionic. Okay, just so that way we don't get too confused. Now nitrogen and iodine, so nitrogen and iodine I. Okay, let's see what we have. 3.04 for nitrogen and 2.66 for iodine, so that will be about 0.38, somewhere around there. But there's also two nonmetals like potassium sodium, so we can move that into the covalent bonds here. We're not going to specify whether it's polar or non-polar. That's not what the question is asking. It only cares whether it's ionic or not ionic. So now after that, the last one, lithium and calcium. So you might notice that these are actually both metals, hence why I threw in that metallic section, because it's not a covalent bond. So lithium is 0.98, calcium is 1.0. Wow, that is a very, very tiny difference, 0.02. And this is one of the rare metallic bonds, not really discussed because they're quite strange compared to everything else. Usually deal with ionic or covalent bonds and compounds, but this is how I would break it apart. So we have iron chloride, magnesium oxide, and sodium fluoride as ionic, and we have phosphate and sulfur here, nickel and, oh, I did phosphate and sulfur, not potassium and sulfur. Well, now you know phosphate and sulfur is not ionic, so K and S. Once again, I do not know the compound for it, but potassium is 0.82, sulfur is 2.58, metal and a non-metal, and this is a better example of something that falls within the range, because this would be about 1.76 if I did my math right. Okay, and that would definitely go into the ionic section. All right, so that is what we have here. The trickiest one honestly would be this iron chloride. Like I said, when in doubt, if it's a metal and non-metal, even if it's transition metal, I would choose that it is an ionic bond. Okay, it's when they start asking for what type of bond it is, I definitely look at the electronegativity, but in this case they're just asking whether it's an ionic compound, so we're just going to default to metal and non-metal. Okay, so let's see how they did it. So iron and chlorine, they do say it's ionic. Magnesium and oxygen, also ionic. Sodium and fluorine, also ionic. Potassium and sulfur, also ionic. So we got that. Nitrogen and iodine, covalent. And now we have lithium and calcium, metallic. So that is correct. And now let's move on to the next question, question 3. Oops.